Alright, we are live. I'm gonna make my face a little bit bigger here. I'm on a, like a diagonal thing this time because I know the questions over there on that monitor, and the typing I'm gonna do is over here. So this time I put the camera in between so I can talk to you in between, going back and forth between the questions, and my code and stuff that's over this side. Pretty open today actually because all I'm going to be doing is talking to people about things and maybe showing people things if people think that they have issues with things that they need to. And I think one of the funniest things about live streaming is you get to see your haircut on a different angle, or for me, the complete lack of haircut that I've got going right now. So let's just make sure, like, while I'm just talking like this, can people actually hear me before I go any further? And I'll just see what people are saying, whether people can hear me or not. I assume if you can't hear me, someone would have said something about it by now. Yeah, okay, cool, everyone's saying that's okay. Well, I know what the delay is now. I know that we've got about 10 seconds, I guess, on the stream delay, which is fairly normal. We usually have that. Okay, so we have, depending on when you're planning to start the exam tomorrow, if you've got other exams and stuff like that, we've got roughly 24 hours. For a lot of people, it's going to be less than 24 hours because I know that the anxiety of having an exam available and not opening it, it would be very, very hard to do it. Wait. Audio is good for some people, but no sound for Nicholas. Nick, I think you may have to check that yourself because I'm going to go with the fact that it's reasonably likely that most people are getting audio because most people said they were. So today I don't have any plan. I don't have any particular schedule that I'm adhering to, but I don't want to like be here for like hours and hours. I mean, to be entirely frank and honest, I missed everyone and I was a bit bored at home, so I thought I'm gonna do a stream. And like the benefit of me getting bored and wanting to talk to you is that you get one final chance to ask me some questions and get a chance to look at some final code and get some final advice. So it's like Mark doesn't get to leave the house and he's locked in and he's bored, and so he's just going to throw in some extra content. Thanks, Raghav. Rajav? Is it Rajav? I assume Rajav. Yeah, I think I said Raghav first, but I'm not sure. You can feel free to correct me. So I think there was... Yeah, like Tom's saying, the exam has been designed for you to demonstrate your skills. Georgia Chicken is here. She's... Oh, Raghav was correct. Ha ha ha. Alright, I'll get that right next time. Chicken? Give me a second. I'm pretty sure she's hiding under my desk right now.
She's gone.
No. She is thoroughly hiding under the desk. I think... Like, she was actually here sitting on my lap before. But she went and sat under the desk. So, I think Nicholas has a question. He was asking, is it the same question you were asking both times? Test 10, question 3. What was test 10? Wait, that's already all finished? Oh yeah, must have all finished, right? Oh, thank you very much, Georgia. Georgia, are you the one that posted on UNSW love letters? Because someone did. That was the point where I was like, my cat's famous on the internet. And I thought that was pretty funny. Okay. So, Nick was looking at delete highest. Ah! Oh no! Someone's got a crush on Georgia. Someone's got a crush on Georgia. That's pretty funny. Not that I want to laugh at people being like, being interested in other people. That's totally fine, if everyone's okay with it and stuff. But yeah, sorry. Just don't want to belittle or anything like that. Oh, CSC Sock hoodie design comp. Has that finished yet? Um, I don't have my own memorabilia. No, I have not opened up a merch shop. I think that would be pretty funny. But it would actually be really funny if I just sold t-shirts with pictures of chicken on it. I had friends that got married and they gave away t-shirts with pictures of their dog on it when they got married, and that was gorgeous. That was really cute. Okay. So we haven't released the answers for week 10, for everything in week 10 yet. We probably should release most of those now. We call it March rather than merge, but it's only sold for 1 week a year, and that's it. Okay. Alright, mine says test complete, which is fine because I have obviously go through it when I'm making sure that it's ready to be released to everyone. Okay, so question 3 here, let's go to the start of question 3, was an example of what a question 6 might be like in an exam. So this is delete all the elements of a linked list that have the highest value. Tom, we can probably release. All right, I've got one sale from Georgia. That's pretty good. Tom, we can probably release solutions now. I mean, it's open book tomorrow, and this is part of the book, so we might as well give them the book. Considering I think the due date is passed for everything except for if people have extensions. Not many people have been asking me about extensions for tutorials and labs. A few have needed them, and that's fine. But yeah, might as well have some of this stuff available. Okay, so this is delete all elements of a linked list that have the highest value. So let's go to the first place I go when I'm working with any kind of linked list question. Is I would think about what this means to us. So it's my whiteboard, right? It's pretty funny. So if I have a linked list, like so, and the values that who was asking? Nick was asking 200, 200. Let me just find my cursor. So it was 200, 223, 45. Okay, so let's assume that and our head over here. I'm going to work on the assumption that our list looks exactly like this. All right, Tom's saying that we're going to release the sample solutions for that. So let's think about what we want to do here. This is, I don't know if this is actually a question 6. This might even be easy for a question 6, depending on what we put in it. Sometimes we're a bit more devious than this. However, there's a bit of work that has to be done here. So what we're saying is we want to remove all the elements in this list that are the highest in the list. So a couple of people are already talking about this, right? So William said he cycled through the list twice. First to find the highest, second to delete everything that was equal to the highest, and trying to make sure you don't lose anything when you do that deletion. So that's the difficult thing. Hugh's also saying, first loop, find the highest, second loop, remove all nodes of the highest data. And George is saying the same thing. So this hopefully is helping you a little bit, Nick, but let's talk through the actual process here. So I don't want to just go, yeah, that's exactly it. So first time through the list. So number 1, find highest. Because we definitely cannot go through this thing and just remove values, not knowing what it was. So the first pass through the list has to loop through the entire list, like so, and then going through the entire list we're going to find out you decision trees and knight's moves. You know the funny thing about that, in a couple of years' time, you're going to be like, remember when I was joking at 1511 about decision trees and knight moves, and now they're like really basic solvable problems. Like if someone said to you, like seriously, if I say to you in 3 years' time, well, I'm assuming that you stay in computing. Not everyone has to stay in computing. A lot of people will jump to different degrees and take on different specialities, and you might not even go into the branch of computing that involves knight moves. But if you do, it'll be really funny, because if I say to you, implement knight moves, you'll just be like, you'll just reel off a series of algorithms that you know solve it, and you'll be like, yeah, I can do any of them in half an hour. So, oh, is it next term? Is it, Tom? Is it that soon? Yeah, I mean, because when I think about a breadth first search with a backtracking, or not even backtracking, because we're not doing depth first. It's actually just what I call a breadth first search would solve that. And I know that that's actually pretty easy to do once you've been taught how to do it. But if you haven't been taught how to do it, and I throw it at you in something like 1511, and it's like, here, I have given you the tools to do this, but you don't actually know how to do it yet. You'd have to piece these things together. So it's a bit difficult. Which is why it's the hardest question in the exam, and it's only a challenge. Okay. So find highest is going to go through the list. You have no choice but to look through the whole list, right? There's no way to find the highest element in the list without going through the whole list, because there's no guarantee that these are in order, as you can see. So if you skip any of the elements in the list, you won't know which one's the highest. So simple. Loop through the entire list. So first thing is a loop through the entire list. I'm going to say using a loop. And this is going to give us 200. I'm going to put in brackets here, save this value. So one of the things that is reasonably important when we're working with a complex question like this is to know what we're going to do, what we're going to save. And so once we've finished this is, I would put this in a function. I would nearly always put this in a function, which is just like loop through the list. And I don't need to implement that function for you, because I'm pretty sure people already know how to loop through a list. Or if you don't know how to loop through a list, this is one of the things you definitely want to train on, is at least loop through the list once and find the highest. In fact, I'm pretty sure looping through once and finding the highest is something that's already been done. And already been done in another lab exercise. So then, and I'll switch to a different color here. I hope no one's color blind. I'm not sure how different these colors will look, but I'm just picking colors that are going to show up against the white background at least. 2, remove all nodes that are value equal to 200. Because I'm not writing on the laptop at the moment, I'm going to take out a lot of the extra words that I could write it. So Yudish, I'm going to come back to your question. It's a good question. Don't worry about that. My face is blocking the value of what I'm showing you, which is awkward because I consider my face to be the most valuable thing. Okay, so my face is out of the way now. We'll talk about that in a little bit of detail, Yudish, because we actually have specific things that we're going to put into those hurdles. Yeah, so what Tom is telling you is correct. It's definitely a certain total number of marks as well as the hurdles. Okay, so remove all nodes that are equal to 200 is reasonably complex, and there's quite a few different ways that we might want to do this. So we could loop through. and remove nodes. Sorry. Just showing how good mouse control I have. People are asking lots of questions at the moment, actually. At least I can answer Hughes quickly. Are there auto tests in the exam? Yes, there are auto tests in the exam. The exam is designed to work in a similar way to the way that we've been asking you to work in general. And we know that in the future, when you start working on general programs and things like that, you will be writing your own tests rather than having tests written for you. But they're things that you're going to use anyway. All right, so let's go back to this here. Okay, so now we've got this conundrum. Remove all nodes equal to 200. So we could loop through and remove the nodes, but every time we remove one of these nodes, we have to be really careful about what we're doing, right? So every time we're removing a node, we have a series of pointers that could get shuffled around in some way or another. So for example, if I want to remove this node here, this 200, I have a huge risk when I remove this 200 of invalidating the entire list because of this. So my head pointer was aimed at a node, and then I'm going to remove that node, which means I need to be really, really careful that when I remove this node, let me just switch to the eraser so you can see where my cursor is. If I remove this node, this head pointer has to point here. So I have to make sure that in the same way that if I was removing a node from the middle of the list, and this is the algorithm that I've taught you, to remove a node in the middle of the list, I need to skip that node out of the list first and then remove it. And that would mean changing the head pointer to skip over this, then removing this. Also, if I'm looping through the list, I would need to set up my current and previous pointers or something like that to now point at the next node so that I can start moving through the list and continue getting rid of that. My solution when that gets released soon is very weird, and I'm not sure if it's the best solution to this, but what I did was I used generic elements rather than writing a solution that was really specific to this problem. So I already had a function that was going to remove a single element from the list that had a single value. So what I did was I got that thing to remove something from the list and then tell me if it had removed something from the list. So basically it would go through the whole list looking for 200 and remove it, and I would loop and I would keep doing that, going through the whole list looking for 200 to remove until it went through the whole list and there were no 200s in there, and it would report to me that it hadn't removed anything, and then I would stop it running. I don't know if that's the best solution. It's a solution that just came into my head when I was working on it, and sure, it's a valid solution to in a certain extent. A more elegant way I would think of doing this is looping through once. So you loop through once and you check each of these, and if any of them equals it, you remove it. But then when you remove it, you just got to make sure all the pointers around it are still pointed at the right thing. Hugh's talking about a recursive function solution. Yes. The way I did it could have been done as a recursive solution. So a recursive solution is something that calls itself, a function that calls itself. We'll get into these more later. This is actually reasonably simple to do for something like recursion. But since I haven't taught you recursion, I had no expectation anyone's going to use that. My solution doesn't use recursion, but it does use a tricky thing where I pass in a flag. We call these things flags sometimes, where we have a variable that just means something and it doesn't have a value, it just has an on-off, like is the flag up or down? You know, so if we're signaling something to someone really far away, I think it's a sailing thing, they would like wave a flag or not. So sometimes I'll use that. Well, I have an integer which is a 0 or a 1, and I'll get the function to run, and I will give the function a pointer to an integer, and then the function will turn the integer on or off depending on what happened. So it says, all right, I remove something from the list, I put the flag up saying I removed something from the list. But if it doesn't put the flag up saying it removed something from the list, it means it's gone through the list and it hasn't found a 200, which means that all of the highest have been removed from the list. So, different ways you can do this. I stopped writing, but hopefully you're still listening to what I'm saying. One way, loop through the list, and every time you see 200, you'd have, okay, let me grab 2 pointers. So we would have a current and a previous. The previous is not pointing at head at the moment, it's actually pointing at null, because we'd usually start the previous at null. So what would happen here is we hit the 200 and the previous was null. That means we know we're removing the head from the list, which means we would get head to skip the 200, and then we would free this node. What happens after that is that this thing's still pointing at null, this thing's pointing at a node that doesn't exist, which means we need to move the current across. So chances are we'd move the current before we removed it. So we'd take the current and we'd move it to this one, and then we'd remove this node, which makes sense for our previous to stay back where it was. And then if we were removing one of the nodes later on, we would have our previous here and our current would skip along, and this one would disappear and the previous and current would still be the same. And then you'd still be able to move through the list from your view this way. Move through the list with your 2 pointers. So the reason why this is a more difficult question for the exam is there are multiple ways to do this, but none of them are simple. So every way that I can think of doing this is going to involve definitely going through the list twice. One to find the highest. That is like a question 2. Like if I just say, well, find the highest value in a linked list, that's the kind of question I'd ask in question 2. Maybe a little harder than that, but not necessarily, you know. That is super basic though, you know, like that's like the first thing I would have taught you with like how to loop through a list. Finding the highest is something where you just have an integer that accumulates, not accumulates, but just tracks which one's the highest. But when you're looping through with 2 pointers and what those pointers point at can change depending on whether you're removing something or not, that's a little bit complicated. And then if we want to do something where it's like, okay, I'm going to remove it and then I'm going to loop through potentially multiple times, removing things until I know I've removed everything that has this value in it, then that involves looping within a loop, in a sense, and then trying to figure out exactly when the correct thing has happened or not. Let me go back to chat and see how people are going with that. William's saying, yeah, we're talking about auto tests. Just because you get 100% for auto tests doesn't mean you get 100 for the question. So that's something I say a lot, because that's an attitude that I want people to get into, because testing in general can never tell us exactly what's going on. So I showed you that little meme of that tweet, which was like, QA tester walks into a bar, orders 1 beer, orders 1,000,000 beers, orders negative 3,000 beers, orders chair beers and stuff, and we go, wait, sweet, we've tested everything. Our first real customer walks in the bar, asks where the bathroom is, the whole thing explodes, right? This is how things work, right? We can think of a certain number of things that we think are going to happen in the auto tests, but nearly all the time, once we hit the real world with our programs, something goes a bit weird, something we don't necessarily understand. So it's that kind of thing where you might think the auto tests are complete, but we can guarantee the auto tests are not complete, because for them to be complete, they would have to have every single possible value that could be put in and every single possible output value that could be generated, and test all possible errors and things like that. And I'm not going to spend that much time writing auto tests, because that would end up, there'd be no lectures. There'd just be a whole lot of auto tests. We'd just be spending all our time making those. Yeah, so William's watching what I'm saying. It's like you maybe need to set the head to the element after if you remove the first one. A lot of edge cases with linked lists, at the beginning and the end, it's always considered edge cases, as in they're not the general case. So anything in the middle, if this is 100 long, there's 98 elements that you would treat exactly the same if you're going to remove them. Except on the edges, the head and the tail, you need to think a little differently about how you're removing those. So again, this is the kind of function that I would ask someone to write, where it's like, okay, this is difficult. I need you to loop through this list and remove multiple elements from this list. That makes it much more difficult to work with, because not only do you need to remove elements, every time you remove something, you have to maintain the structure of the entire linked list, maintain the head and the tail, make sure the last one's pointing at null in the linked list, and on top of that, make sure that if you're moving through the list, that you're not skipping over elements in the list, and you're also not doubling up on elements. You're not accidentally removing more than one at a time or anything like that. Oh, interesting. Tom's saying that someone was saying that a nice way sometimes to do this is to go through all of the elements except to the first node and do everything you need, and then only fiddle around with the first node when you're done with those, because the first node's the one that's the trickiest, because you've got to move the head. So that's an interesting thing. I could see that working. Yeah, recursion would be interesting. And as George is saying, semaphore. Yeah, semaphore's the sailing thing where they can say lots of things with flags. Sorry, I'm just watching pictures of myself and waving my arms around now. Which reminds me, the reason I put this jacket on today is May the 4th be with you, everyone. And I find it a little ironic and also hilarious that you have to do your exam on Revenge of the Sith. So, Revenge of the Fifth. I said Sith and Fifth at the same time, and it didn't really come out as a word. Yeah. Okay. So Nick is saying that first element cannot loop through. I'm not sure exactly where you're going with that, Nick, but I think that you're hitting the idea that, yeah, if you're removing the first element, you're in a situation where you're unable to continue looping into the rest of them, and this is all going to be a matter of tracking these pointers and when they move. So if this is your current pointer and you're going to remove this node, let me go back to where it was here. You can't remove this node while your current pointer is here. You need to move your current pointer here, which means you need another function that's going to remove a node with another pointer, or you have a excuse me, you have a separate pointer, which is like this one, called the remove pointer. Rem pointer there, and then you've set up your rem pointer. You take your current pointer and you move your current pointer here, and then you use the rem pointer to remove this one, and then you have looped onto the next one. So that's why this is something like a question 6. I don't know if this is even as hard as a question 6. I think a question 6 is probably harder than this. That you have to keep in control of whatever you're tracking with this kind of thing. Tom's talking about edge cases. Yeah, there's always things to think about, because a linked list may have 0 elements. It may have, I'm saying 0. It may have 0 elements. It may have 1 element, or it may have many elements. And those are always very interesting, because you need to make sure that you can deal with all the situations. Like if the head is null, you need to do something. This one's really easy, right? Because we've been told to remove nodes. If there are no nodes, it's really easy to remove nodes. In fact, we can skip part 2 of this entirely. So if I say find highest using a loop, and I cannot find the highest because there is no list, then I could just return null, right? So if I'm going to give back a list that has the highest removed, except that list was empty, I can return an empty list without looking into it. I don't even need to go through removal or anything like that. And I think I've got that in the solution, where I just said find highest. If I can't find a highest, just return, like there's no more in this, just return null, because the list is empty. I can't remove anything from it, so there will be no removal. Give back the empty list. So there were some questions back up here. I'm not going to go necessarily into code for this. Unless you want me to. Actually, no, I don't think so. Oh, well, we'll see. We'll see. I might come back and go into code for this if there's time. But I know that if I just did this one question, I could do this one question and it would take us the whole rest of the time. But I want to cover a few other questions. Raga saying the solution did not feel clean. Sometimes the linked list solutions don't feel clean because you have to jump through lots of different things and you've got to make a lot of different changes. Okay. What were other things? There was a question back up here. Yudish was asking, would there be a bare minimum we need to do for a pass? So this depends on how many marks you have in the course so far. So if you're in the course and you're looking at, your labs and your weekly tests and your assignments, your second assignment's not complete yet, but you will know roughly at least how many stages you completed. So you have a certain level of confidence going into the final exam. If you think that you've got kind of, say, 30% of the course's marks so far through labs and tests and assignments, then going into the exam, you don't have to do a huge amount in the exam to make it all work. Actually, no, we need to get more than 30%, but roughly. You need to get a total of 50%, which means you look at the marks in the exam and you go, okay, if I'm currently, at about 60% completion, then I'm going to need to complete about 40% of the exam. Roughly. They're not exactly 50-50. The classwork is worth 55 and the exam's worth 45. But if you want to, you can juggle the numbers and have a reasonable idea where you're going. Having said that, we haven't marked assignment 2 yet, so you can't really juggle the numbers. I would still like everyone to put a full effort into the exam that they can, but you do want to have like just the peace of mind of knowing whether you're actually passing or not. I've got my lecture slides here. So one thing to look at is the marks breakdown of the exam. I think the marks breakdown in the exam, I don't know if we've said exactly what the questions in the exam are worth yet, but that'll be in the exam paper tomorrow anyway, so you can always check that out. Also, like, you got 24 hours. If you want to, you can spend the first hour going over your previous marks in the class and going, okay, if I add all this up, this is what I need to do. Exam questions. So if we want the bare minimum, then we want to look at these first hurdles. So let me just make sure my face is not covering up anything at the moment. So the first 2 hurdles, one question is going to be on arrays and one question is going to be on linked lists. There's a few things that you will need to be able to do to make these work. You should be able to use if statements, you should be able to do loops. At the bare minimum, to pass these questions, not even 100% these questions, but to at least pass these questions, you need to be able to loop through an array and loop through a linked list and see every element. We'll ask you to do something with every element in the list, but what that is differs depending on what question you get. Not everyone's getting the same questions either, because we understand that, like, you're all on Facebook chats. So you're not getting the same questions, so that if you talk to each other about your questions and you answer like someone else's question, then we know that you've been doing something dodgy. So we are watching you, and this is still an exam, right? So we're not really watching you, but this is still an exam. We still want you to present your own work. So I hope people will. You don't get very useful feedback if you present someone else's work, and all it means is, like, you go into subjects later and you're like, why is this subject so hard? We were never taught this. And it's like, yeah, you were. Anyway, I don't want to. Yeah, it's such a rabbit hole. It's such a long and deep and horrible rabbit hole to, like, chase people for cheating and things, and then try to get it to the point where everyone's being 100% honest about what they're doing. But really, it's, there's only so far I can go with that. I think it gets to a point where you got to be honest with yourself about what you're doing. And I'm quite happy that the majority of students always are, and the majority of students are actually here looking to get value out of their courses, not looking to get a piece of paper at the end that they don't actually understand. Because you get plenty of people who get given a degree and they don't actually understand what they did to get there. Actually, that's a different conversation entirely. None of us understand what the hell we're doing, but but at least we know that we muddled through with our barely passing and got our degrees honestly, and then we know that everything that piece of paper says we can do, we can actually do. Anyway, I don't want to go into that too much, but just just try to get the most you can out of the subject. There's going to be more learning in the assignments than in the exam anyway. The exam is just like, you need to do this. Okay, so back to what we're doing about passing. I'll give you the format of the first two questions is nearly always going to be similar to this kind of thing. So this one is an example question that we talked about before. This, I think, is a lab question, if I remember correctly. I don't know whether whether we put this in a lab or a weekly test already, but heaps of the questions that are the question ones in the weekly tests and the early lab questions are going to be really similar to the questions 1 and 2, especially a level of difficulty, not necessarily content. So question 1 will nearly always be loop through an array and gather some kind of information. So this one says the information I want you to gather is all of the even numbers. Hang on a second. Hello. Oh. We got someone to say hello. Can you wait? Let me just. There we go. Oh, I'll tip it down a little further. You don't need to see me anymore. You can just see chicken. Yeah. So this question here, we're talking about even numbers here. So it's like, go through this list. So this is a single loop through the list, and as you do the single loop through the list, if you find an even number, you print it out on a line on its own. So you can see how it's not just looping through a list, it's also doing something with that list and getting some information out of it. Everyone's like, yep, this is the moment we were here for. This is more important than the lecture or anything. Well, especially because this is only an Ask Me Anything. So another example possible question here is, given a linked list, add up all the values stored in it and return that one integer. So similarly, you have to go through the whole list. So in going through the whole list, I wonder if she's going to look at the camera. She's sort of looking a little bit at the camera. She's just sort of looking around. Single loop through the whole list. It's usually, the first two questions are usually going to be a single loop through the whole list. Everyone's like, wow, you don't need me. No one's listening to me anymore, are they? They're just like, this is chicken. Chicken. Hello? I'm trying to get a look at the camera, but the camera is like flat out not interesting to her. So, you know. But that's alright, she'll just hang out here and get some pats for a bit. Yeah, Peter is saying chicken's being more comfortable on camera. The funny thing about it is it just got colder. So beforehand, like when we started going live, it was still like 30 degrees. And so she's just like lying on the floor somewhere trying to cool off. But now that it's colder, she's like, oh, I want laps, you know, so I want somewhere warm to sit. So she's like actually coming and sit on my lap when I'm talking. Okay, so this is going through and adding up the numbers in the list. And so it takes a little bit of effort because you've got to know how to put a variable inside a loop or outside a loop, because if you want to add something up, you need a variable outside the loop. So you can see these two questions together are testing two different things. One is like, can you look at everything in the list and do something with it? The other is, can you look at everything in the list and accumulate it? But both of them are going to have looping through the list. These are the basic the basic hurdles, which I say are the basic competency you need for me to be happy that you're capable of doing the basic functionality that we expect in Comp 1511, which means you know how to work with an array of things, you know how to work with a linked list of things, and you know how to do looping. Hidden in amongst that as well is you know how to do output. You may know how to do input as well. Not all of these are going to do scanfs. Some of them might. These ones both say edit a function, which means that you don't need to know what's happening. You'll get past the values in the function. But it still means you need to deal with a data structure. We may have these which is like, all right, scan in these numbers and make it into a data structure and do something. Yeah, so using variables, scanf, printf, if statements, and loops. One's are use of arrays, the other's use of linked lists. It's very, very unlikely. I'm pretty sure it won't be the case whether we're going to ask you to build a linked list in question 2. We might ask you to build an array because it's easy, but building a linked list is mildly difficult, so it's not the kind of thing we'll necessarily ask you to do. The other hurdle questions are questions 3 and 4. These are going to be a bit harder, so I would generally suggest, like, if you're looking at barely passing the course and you're not really sure about what you're doing, then questions 1 and 2 are where you want to focus on, because they're where you're going to get your marks. Because 1 and 2 together are worth 30% of the exam, and that might be enough to get you over the line. I don't want to start doing calculations of exactly how many marks everyone needs to pass. I think you just want to focus on doing a reasonably good job for what you're doing in the exam, and then you'll get the appropriate feedback for how well you're going. Because that's the other thing about the exam. It's not super a learning experience, but it is somewhere where you can get feedback on whether we think you have the capability to do things or not. So that's what the tests are pitched at. People are asking why Chicken doesn't have an Instagram account. I could start an Instagram account for Chicken. I do have a certain level of experience with working with Instagram, so yes, that could be possible. I don't know if I will. Raghav was saying that thank you for going open book rather than Examity. I'm not sure I like Examity. I know people do it and things, but it's a bit messy. I don't entirely like the level of invasion of privacy, and also the idea that someone can have a program that can take over your computer. Like, I know that, people always say, oh yeah, it's safe and stuff like that, but every single system that anyone has ever said is 100% safe has broken at some point. Every single system. Even all the systems that are like for the most dangerous things in the world, like things that control things like nuclear reactors, things that control spaceships and stuff like that. The stuff that people put, a whole lot of extra effort and a whole lot of extra hours into making sure this thing can never fail. A lot of those things have failed. And I have no confidence that Examity has the same amount of effort put into it than the space shuttle. So I don't think that it is necessarily safe, and I don't think it's completely devoid of security risks of someone being able to take over your computer because Examity's on it or something like that. I don't know if I'm just being paranoid there or anything, but it's something that I'm not. Also, I mean, like, even if it was secure, I just don't like the fact that we're poking into people's homes. If you were not forced to be at home, and you could do an Examity exam from your local library or something like that, where it has no way of getting into your private information, then maybe I think that'd be okay. If you could book a room somewhere else for free and do it. But without that, it's kind of like, yeah, we're going to get a camera into your own home and you don't have a choice. And that weirds me out. As I feel like it should. So, Boris is saying, do I have any tips for how to structure a response to get full marks for a question? My advice for this is to structure it exactly as you would in a lab exercise. In these programming questions, so where the bulk of the marks for the exam are, the format of how you're going to submit is very specific. You're just going to submit a C file. I think where you don't have any multi-file questions. So every single question is going to be in its own C file. So you would write a program in the C file and just make sure it runs cleanly. You don't have to go in and fully comment it, but I would make it at least all indented correctly and things like that, because someone is going to be looking at most of these. We're not necessarily going to be marking 100% exact everything. Like, what we're going to be doing more likely is, because this is a pass-fail course at the moment, and we've actually been told we're not allowed to release exact numbers to everyone about everything. We're going to release all of your auto test data so that you can see how well you're doing against your tests and you get some good feedback on what's going on, but we won't necessarily be releasing an exact mark. So we will most likely be saying this person got, say, 30 to 40% of the course covered in the coursework, and then they got past a certain amount in the exam, and then that's enough. And then we'll be like, all right, we're just still going to let them know what their auto test data is, but we're not going to bother marking questions 6, 7, and 8 because they've already passed the course. And they'll get feedback on it anyway, because we'll tell you what's happening with the auto test, so you'll know whether you completed it or not. But we may not end up marking things all the way through to the end. Rogov, Mark, can you do a gaming live stream? Do you want me to just, like... No, I'm not going to do that right now. I can fire up Borderlands in a second and just, like, show you my epic level 57 endgame builds for Borderlands at the moment, where I'm beating the hardest content in the game. Because you want to know that, right? You want to know that if you're going to learn from someone, that they can totally own at games. That's important. Anyway. So we're talking about how to pass. Sorry, I'm just going through the chat. I'm behind in the chat and making sure I'm answering everything. Yeah, so how to pass is definitely the hurdles. So these 2 questions will get you 30% of the marks in the exam, as well as making sure that you get past the hurdles. If you want to, you can go for the harder hurdles as well. You only need to pass the easier hurdles, questions 1 and 2, to pass the course. If you pass the harder hurdles as well, yes, good. Nothing wrong with that at all. If you happen to make a little mistake on one of these, you misread the question and you answer incorrectly or something like that, but you do get one of the harder hurdles correct, that still passes the hurdle, right? So you still only need to get 1 linked list question correct and 1 array question correct to pass the hurdles. So that's the first 4 questions. If I'm looking to just pass the course and I'm not sure, then those are the questions that I'm worried about. Those are the questions that I'll work on. I'll put Chicken's face back in the shot. Are we able to use our own code written in the course for solutions in the exams? How does it work with academic integrity if you're reusing old materials? Yes, you can use your own code. If you've written your own code, you can use it. This is an open book exam. An open book exam means that all of this stuff, all of the lecture slides, is available for you to use. So it's technically possible. I mean, like, it would be super difficult, but it is technically possible for someone who has not been in the course at all up to this point to open the exam from nothing, open the lectures from nothing, and start watching them at like 2 or 3 times speed and get enough out of this to pass the exam. They're not going to pass the course because they haven't actually got any marks for the labs and the tests or anything like that, but it is possible if you're one of those people that can learn 10 weeks worth of content in 24 hours, it's technically possible that you could pass it. So you can use things. I mean, it's unlikely that there's anything in these questions that is that simple that you can copy paste out of lecture slides or lecture code to do it. But there is a significant, chance that makes sense. So you could say, okay, Mark did this thing, or this lab question did this thing, which is similar to this. Now all I need to do is take that structure and change it so that it works for this question. You got to understand as well that we're in a little bit of uncharted territory here. This exam wasn't necessarily written for open book. I think if it was written for open book, I would have been much, much more devious with a lot of these things. But I didn't really have time to rewrite an exam. Exams take a long time to build up. you will notice in a lot of the multiple choice questions that I've written a bunch of them. So I actually left some of those in as freebies. It's a very small percentage of the exam. It's like 5% of the total exam, so it's not much, that you can get the answer by running them. And because it's open book, you can just open up a terminal and run them and stuff. So I guess a certain percentage of the course is me testing whether you know how to use a compiler and actually run a program. But some of the other multiple choice questions that I did manage to rewrite for this exam, even though they're open book, you can't answer them easily. You actually have to understand them to answer them. A lot of the programming questions, they're not exactly the same as what's in the lectures as well, so you're going to need to think about that. If you really want to, I've said this before, I don't know if anyone really wants to do that, do the exam in exactly 3 hours, not looking at any notes, and then see how you go. I don't know if anyone really wants to submit at that point after 3 hours, but you could treat it like your weekly tests, where in the weekly tests we said, okay, after 1 hour, how did you go? Have a look at how you went. There's your feedback. That's the level that we're hoping people can reach once they're comfortable with content. So this could be considered 3 hours. And at the end of 3 hours, most students, I'd say the majority of students, will be able to complete the first 4 questions. Less students will have results for 5 and 6, and maybe 5% or even less than 5% will be able to do question 7. So it's at that level for the 3 hours, and that's usually how we end up ranking everyone. This term we're not ranking anyone at all because we're on a pass-fail. Okay, so other questions. Simply Me Joe says, can you talk about the difference between character pointer variable versus character variable length? Is it possible to initialize strings using string copy, or do you have to initialize it first before you can copy? Okay, let's hop over here and have a quick look at some of these things. Where am I going to put stuff? Stream code. I have a random directory for random things that we put in streams. What are we looking at here? Declaring strings. Stringdemo.c. I was nearly going to call it strings.c, but there's string.h and stuff, so I don't want to get too compared with that. Oh, what am I doing? I'm just writing a name without the gedit. Okay, so question was, let's you can tell I'm like reaching around my cat to type right now because I'm just like missing keys. I'm gonna move this over so that Chicken doesn't get in the way of the code. Alright. Okay, here we have our basic little program, and we had the option of, let's just go, okay, this is a name, and this is a other name. Yeah, great variable names. And this one might have a fixed length, which is like, we'll define a max length to be 256. One of those little computing numbers, powers of 2, that we use a lot of the time. Okay, so at the moment, the difference between these two is this is a pointer and this is a piece of this is a piece of memory that we're using that is put into the memory for this function. So it's not allocated memory like a malloc, but it is in this function. So sometimes these are reasonably similar. So we can do other things where it's like, I'll I'll make a function here called void print name, and this takes in a name of some kind. And so I can do this. Printf. Oops. And I'd be able to pass each of these in here, except this one at the moment just doesn't have anything yet. So it's like a gap right now. Let me just make sure that I'm not... I'm just making sure that like what we're talking about here. Oh yeah, so Tom's talking about how it would work in the lab computers. Oh, Shrey's here. Shrey's been here for a while, isn't it? How's it going? Shrey actually did this course earlier on in the year, and he's also one of your CSESOC people who's been helping out and stuff. Wow. Michael, is that actually happening? Unis are asking people to speak the code out loud. I mean, look, there is a decent idea that I was talking to some of the other lecturers about, which we don't have the time or money to do, but it's to interview every student individually. So what we'd do is let you take the exam, and then what we'd do is you'd sit down with a tutor for 10 minutes, and we say, all right, you did really well in this part of the exam. Please describe to us what you coded and how it works. And so that's one of those like really classic ways where you can just be like, I know if you cheated because you can't explain your own code. You know, it's beautifully written code that people can't explain. It's like, oh, there's a red flag right there. We're not necessarily doing that because I think I explained this before about exams. I just don't have the time for that, right? I don't have the time to go through and check everyone's stuff. Okay. Oh wow, Hugh was writing it out by hand. I will definitely do by hand stuff when I'm talking about diagrams, but not necessarily about code. People are like, Mark hasn't realized we're only here for chicken. Oh, chicken's gone. Oh, she's decided to go away. Oh well. You're stuck with me now, aren't you? Yes. Back to your actual lecturer who you're all apparently paying thousands of dollars in order to learn from, as opposed to my cat, who you could purchase a cat much like mine for much less money that you've paid for the course. Oh, Georgia, burn! That's, you know, she might be back. You know, this is not like she's just walking around the room. I've got her locked in the room at the moment. Anyway. Okay, back to what we were talking about, because we had a question about strings. So at this point, there's a subtle difference between these two, in that this one is a pointer that is not aiming anywhere at the moment. So this is rough and messy, and so if I was to pass this into this function right now, we'd have a problem because it doesn't have a value, right? It's not aimed at any memory right now. This one does, because this one has a piece of memory it's been given, which is this, and it knows the address of that memory in this name. Let's I'll show you, right? Let's call print name, and we'll put that pointer in this one, and we'll put the other one in this one, and let's compile it. And I literally don't know what's going to happen here. You know what? I'm going to clear my terminal before I start doing stuff like that. Okay, string demo.c. I'm going to output that to string demo. Oh, good. This is good. We're getting a warning. Great. I've managed to convince Georgia to stay because I've said that the cat might reappear. I realize this is the point now where people no longer care about my teaching anymore. It's about my cat. I'm not entirely against that idea. Are you against that idea, Chicken? She's not talking. Sometimes she will talk. She might talk later. We'll see. Just quickly, Usman's asking there if CSE subjects will be graded pass-fail next term. they're not expected to be pass-fail next term. We're trying to make all CSC subjects numbered marking next term. I think this term it was because like one of the big issues was we changed the way that things were being assessed midway through the term, and that was considered something that was sort of too much of a shock to necessarily keep the numbered marking. It's difficult. It was really difficult. There was a whole lot of controversy about it when it went up. I mean, you can go back and watch my stream because I was in shock when it happened as well. So I was like, I don't know what's happening. So we made it work, I think, and we'll see how it goes. I mean, look, honestly, in the overall scheme of things, how you do in Comp 1511 is not necessarily indicative of how you're going to do in your whole degree. I mean, I'm just thinking about this in hindsight. I think my Comp 1511 mark was exactly the same as my WAM when I finished my degree at the end. But that was a coincidence, I feel. I shouldn't have said that. I'm just invalidating my own point. I had other friends who started off really badly in Comp 1511 and end up honors students at the end, so it's not something that has to force you into one thing or another. I think as first year students, you're actually in a very good position. Well, not everyone here is first year, but most people are first year students. You're in a pretty good position because your first term is a little bit disrupted, but from then on, things are going to go back to the university doing its normal teaching and things. Like when things get really hard in the later years, you'll have all that in-person support that you need. Okay. So, we were talking about strings, and we were talking about the difference between a character pointer and a string. And here we see the first subtle difference between these in that this code here has not been initialized to anything, and because it hasn't been initialized to anything, it has trouble going in here. Because this thing is going to expect a pointer address that goes to a certain location where it can read a string, and this one provides that. It provides an address that can go to this many letters, or however many letters are in there. We haven't put anything in either of these. And that changes what happens. Okay, so we've got a warning there, but this thing will still run, so let's try running. It's going to break something, but let's try running it anyway. Oh, oops. Name, uninitialized string value, cannot access memory at this address because the address is not valid, right? So that's the issue that we're getting. However, we can do the following. We could do, I'm going to put these on separate lines so that doesn't cause issues. We can declare strings like this. So this is a character pointer, which gives us the address of this initialization. This initialization will actually do the letters H, E, L, L, O, and it will have a null terminator there because the double quotes turns whatever characters we put in between it into a string, which means it automatically puts a null terminator there. So this declaration will actually create an array of characters that is exactly long enough to hold 1, 2, 3, 4, 5, 6 characters. So I added 1 on the end because that's the null terminator. This one will give us a string that can hold exactly 256 characters, and it will put these 6 characters in. 1, 2, 3, 4, 5 for world and a null terminator. The rest of it could have anything. We have no guarantee what's in the rest of that because we just grabbed a chunk of memory. Could be other stuff, or our compiler could be really nice to us and make them all zeros, which is all null terminators, but we don't know for sure. And so now if we work with this, these two are actually going to appear the same because what's happened with both of these is both of them have assigned a certain amount of memory. They've both put stuff in that memory with a null terminator at the end of it. So this one's much shorter than this one at the moment because this one had a specific length. But both of these are now functionally identical because what they are is both pieces of memory with characters in them and an identifying name which gives us the address of the first letter. So remember that an array, if I use an array by name here, So I don't use square brackets to get a single character or anything like that. Use the whole array by name. That gives me the address of where the first letter has been stored in memory. This pointer also gave me the address of where the first letter was stored in memory. So if we run this, if we compile and run this, we might get... Wait, I'm going to clear my console before I do that. We might get a different result than we did last time. So this time it's compiling happily. And then we run it. And it's giving us hello and world. So the difference between them is subtle, and it's only a difference if they're used in a particular way. So if they're used in a way without initialization, then we have an issue. Because without initialization, they are very different. With initialization, then they both have memory attached to them. Without an initialization, this thing has no memory attached to it. So this thing is just an address of something. So it doesn't... I shouldn't say it has no memory attached to it. It has enough memory to store a pointer. But it doesn't have... it doesn't actually link up to any characters anywhere else. This thing specifically says, give me 256 characters worth of memory inside this function, and we'll use other name to reference that memory. This one says I can reference some memory, but I don't have any yet. Put those back. So when we're using them, we have to be a bit more careful like that. The question that was also talked about there was like, can we use string copy to do stuff with that? Yes and no, but we can't do string copy in an initialization. Tripping over my own words. So I can't just say char star name, as in pointer to something, equals string copy something, because string copy requires there to be a string to begin with, and also it's not going to give me a string, so string copy doesn't output a string. So even if I did string copy source and destination, so source, I'll chuck an actual string in here, hello, and the destination is name. So I'm saying I want to copy hello into the pointer name. This doesn't even work. Actually, no. What if this was like this? So there's still an issue here, right? The issue is I'm trying to copy the letters hello into a string, and I think this is a string because it's a character pointer. Except this thing, because it hasn't been initialized like this one has. Actually, even if I do this, if I do this, this still has memory with which to do things. This thing has no memory. So because it doesn't point to memory anywhere, I can't write to memory anywhere with this. So I can't write hello into that string. I'm not even sure if I've got the string copy format correct. I'm pretty sure it's the source, then the destination. So this one won't work, but if I was to do the same thing here, this one will work, because this one actually has memory that you can write to. This one doesn't have any memory you can write to because it hasn't been assigned to anything, nor has it been initialized to anything. If I do something like this, then this will work, and I will overwrite this string with this one. So it will overwrite the first 5 characters with hello, and then it'll put a null terminator there, which means we will use the first 5, which will be hello, and we'll ignore all the rest of this that's in there. So this can work, but this is a different initialization. So there's only a subtle difference between them, but they will be different. Once they're created, and once they have access to memory somewhere, they can be used interchangeably. So if I have character, actually we'll just put that blah 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 back like that, and I copy hello over it, I can still do something like this. So I can change the capital H hello to a lower case hello. I can still treat this thing like an array. Yeah, so even though I declared it as a pointer, I can still treat it like an array, because I know that I have initialized it as a chunk of memory. You got to be super careful doing things like this, because if I do this here, I will break something. Right? I will go off the edge of this memory and try to access memory I'm not allowed to, If I do get access to that memory, it's very bad, because it could just be another part of the program that I'm overriding, and it could cause it to crash. Some compilers will let you do that. DCC will not let you do that, or it'll say, no way, this is out of bounds. We need to turn off the whole program. You can't do that. But if I'm careful and I'm in the right place, I can access this like it's an array. The issue with this is I will know based on the length of the string exactly how big this piece of memory is that this character pointer is aimed at, but I won't be sure later on in my code exactly what that number is. The safety of using something like this is I know that I will always have 256 characters here, even if a lot of them aren't going to be used because they've got null terminators before them, or just a null terminator before them. I have a guarantee of how much space I have in this one, whereas this one I don't have a guarantee. It's just based on this one line of code, and I won't know the number of how many things are in that unless I do another function to count how many are in it. So yeah, so there's the subtleties for the characters. I'm gonna have to go back up because I think there's a lot of text chat that's been happening, because there were other questions I was going to go back to. Oh yeah, okay. So that was the question about strings. Just going through. I'm going through all the chat now to see if there's any other questions I want to answer. I just found the section again, which was like, people are saying they would watch a chicken only live stream, and why doesn't chicken have an Instagram account? Where is she? I don't know. I think she's either under my desk or she's sitting up in the window. She likes to sit up in the window because it's warmer there than in here. People are like, you're only here for chicken and my gaming content. I'm gonna quit being a lecturer and just stream chicken and me playing computer games. There's been a lot of computer games playing here just because not being able to leave the house is kind of annoying. Been playing a lot of Overcooked with friends actually, which is really funny because there's a whole bunch of like production managers and project managers and stuff. I don't know how that happened, but a whole bunch of my friends are that. So playing something like Overcooked with them is really interesting because like stuff just magically turns super efficient instead of the normal chaos that is that game. All right. Rarov was asking if we normally would have sat the exam with pen and paper. No, we would have done it on lab machines. Oh, that's been answered. Yeah, so what we would have done was we take the whole course and put you in all the labs that you're in for your labs. One computer per person. We've got special partitions we put up so you don't look at other people's screens. And then you would be asked to do the exam in a specific environment that doesn't give you access to the web. So you wouldn't have any lecture slides, you don't have any like Googling C references or anything like that. You just have to do it off your own memory. So the interesting thing is the exam, as you can see it, would usually be much harder than it is. We haven't bumped up the difficulty of the questions very much. We have a tiny bit, but not very much. So the exam is actually quite similar to what it normally would have been. Yudish was asking what the average would be like for the assignment in previous years. I think I actually spoke about that, where what are we getting the average final marks? Like the average final marks for this course are usually in the low 70s, which would mean that someone had done usually very well in the coursework, because it's easier to do well in the coursework because you've got so much time to do it, and then they would have gotten maybe 60-70% in the exam at most. No, that's way too high. Like they literally would have been getting like 50% in the exam. Like 100% in the course content and then 50% in the exam gets you about a 75. I should actually say that as well, that the exam that we put up is kind of, well, I talked about this with I think it was William at the beginning, that this was even before we started the stream, I was typing this, that a lot of exams do this idea of destructive testing. So destructive testing is what people do when they're testing safety equipment. So they'll manufacture all of these, let's say like rock climbing harnesses. They'll manufacture like 100 rock climbing harnesses, and they'll take one of them, and they'll go, okay, pull this thing until it breaks, and they get to the point where that one out of every 100 that they test breaks at 2 tons. So it takes 2 tons of pull on this thing to break it, which is way more than any pressure a human would ever put on one of these things, even falling from a great height. I've done that, by the way. But we'll talk about that another time. That kind of testing means you know exactly how strong this thing is by pushing it all the way to the end. Comp 1511, the exam, does a similar thing where the escalating difficulty in it is to the point where, especially if we were to do it in only 3 hours, the escalating difficulty of it would be that pretty much no one is able to finish the entire exam. Because if we want to assess you correctly, it means we have to assess the entire breadth of people who are doing Comp 1511, which means we've got some people who have been doing programming competitions all through high school and all this kind of stuff. And so, honestly, like, in terms of this stuff, this low-level C, like, quick, reasonably well-known algorithms to just hammer them out, I'd say there's a percentage of the course who are, like, easily better than me at that, because I don't program for speed. I tend to, like, obviously, right, I'm a teacher, program for clarity and readability and things like that. I don't program to get a whole lot of code out really quickly. Programming comps will get people programming in this really, really high speed format. And so I've had one person out of the last 2,000 or so people that I have run this course with, around 2,000, just under 2,000 people. I've had one person get 100% in the exam. And that was a really interesting situation. I remember my course admin saying, hey, someone 100% in the exam. This is the first time I've seen this, right? So that's where it's supposed to be. It's supposed to be so that I can see exactly where everyone's at. If I made the exam easy, then everyone will get 100%, and I have no idea how good anyone is at programming. So that's why it's like stupendously hard. And so for some people, you're going to look at it and you say, how is this even supposed to be possible? And the answer to that, it is not. So it's okay if you don't finish the exam. It's okay if you focus on just the hurdle questions and stuff like that. You don't ever have to be in a situation where you think that you need to get 100% in everything. And a lot of universities are going to be like this, all right? So this is why whenever I release an assignment to you, I talk about the assignment and I say, this is what I think people need to do to pass. This is what I think people need to do to credit. And then if you're chasing an HD, this is your stage 5. And this is your Hall of Fame if you're even wanting to push beyond that. Hey Tom, is the Hall of Fame up? I think the Hall of Fame is up somewhere, right? I can't remember whether that's actually been publicized or not. Because I know I haven't actually publicized a notice about it. So it'd be bad if you actually have it available, but I haven't publicized it. Because a lot of you did submit Hall of Fame stuff for the first assignment. And we probably should make that visible to people. Anyway, people asking about grading pass fail in term 2. I think I already answered that, didn't I? That we are going back to numbered grading then. Was mine saying, is it advisable to do Comp 1521 next or 2521? I'm not sure. This is something that I would talk to with people from CSE SOC. The person who manages the CSE SOC mentors is in this chat right now, so Shrey might be a good person to talk to there. You can find him on the CSE SOC Facebook page. CSE SOC also has a Discord and a Slack, so you can get on either or both of those and ping him and ask him questions. It's not just him. Anyone who is in second or third year is probably in a situation where they know a bit about how these courses ran. All of this evidence is going to be anecdotal, so it's a matter of talking to people about it. I was about to say you could try emailing the lecturers of those courses, but I don't know what kind of answers you're going to get. or if you're going to get answers at all. Lecturers tend to be some of the most overworked people in the university, especially anyone that lectures a reasonably large course, and all of these core courses are large. None of them are bigger than mine, obviously, but but they're still huge. So there's still the point where lecturers have trouble dealing with the admin load. So I get a lot of emails where I have them in my email inbox as unread, and I'm like, when I get some spare time, I'm going to go back and I'm going to go talk to those people. And I hate to say it because, like, I think the oldest one of those is at least 3 months old that I need to go back and talk to people, and I will try to eventually. But the flow of incoming emails versus my chance to read them and reply to them is, I just don't have the time, which is really, I think, a shame. But I'll try to get to them all eventually. I think if anyone's tried to email me directly, you would know this, because when people email my actual personal email address, they get an automated reply that says, "Don't email me here if you're asking about Comp 1511." It's just not going to get answered. So it's pretty funny. Yeah, but I think talking to other students about those courses is better than talking to me, because I don't go to those courses. When I did the courses that were similar to those, they had different course codes, different course names. They had different lecturers. I mean, it was like 20 years ago, right? So it's completely different lecturers. Not completely. Some of them were there. I'm actually working alongside some of the people that taught me things originally. People like Richard Buckland, Andrew Taylor, and stuff. There's a few key names of people who have moved on to do other things since, so it's not exactly the same, but some of the lecturers are the same. I find it quite interesting that people can teach the same content for like 20 years. It's quite impressive. I was about to say I would get bored of that, but then I look at like the number of hours I've spent in World of Warcraft, and I'm just like, oh no, I can do the same thing for 10 years. Anyway, okay, other questions. People talking about textbooks. I mean, as you kind of know, I never referenced the textbook in Comp 1511. The textbook is there just as, like, if you prefer books. But, you know. Oh, Hugh actually did use the textbook. So that's good. I mean, like, sometimes it's nice, right? Sometimes it's nice to, like, regardless of whether you do or don't like my content, or if you don't like my content, it's very nice to have a textbook. But even if you do like my content, it's good to look at the way other people do it. Because if you look at a textbook, you might find some really, really interesting other ways to do things. Because sometimes I'll teach you something because of certain restrictions. So sometimes I'll teach you something specifically because I have 2 hours with which to get a topic into people's head. So I will do it in a really, really specific way, a really specific, simple way that makes sure that it gets into people's heads, and it doesn't get into your head completely. It just gets enough into your head that you'll think about it again later. Oh, hello again. I'm going to try and sit. All right, I'll move the camera back down. Somebody's back. Yeah. Oh, people are mentioning assembly. What other people asking? 1511 textbook apparently was quite dense. Well, that's really interesting. So Hugh's saying that learning from the textbook with my teaching got him to the point where he could do one of the assignments in 3 days worth of work, after not having done programming before. So I'm glad that that's happening, because Comp 1511 is designed to be able to be completed by people who have not done programming before. And I can't say that that means it's able to be completed by anyone that hasn't done programming before, but there's going to be a lot of people who haven't done programming before that can do the competency necessary for 1511. For a lot of people, Comp 1511 is a major shock to the system, because we do a lot of programming and it's not immediately understandable, just because programming itself is not immediately understandable. So I always have this in the back of my head as I'm teaching Com 1511, is this implicit apology to everyone who hasn't been able to pick everything up at the speed that we have to teach it at. But we do kind of have to teach it at that speed because I have a certain number of weeks in the term and a certain amount of content that I want people to know by the end of an introductory course. But I hope that it's the kind of thing where it'll eventually sink in. Like, when I say the average mark for the course is somewhere around 70, that means that on average I expect people to only know, it's not even 70% of the work, I would say 50 or 60% of the work that I've gone through for people to genuinely understand it, right? And then you go on and use those things again, and you'll learn them better when you see them next. Oh, Tom saying more than one person got 100% in the exam? I don't know. Oh, no, right, you're right, Tom. One person got 100% in the entire course, and only one person last year did that. And it's not this term, because we haven't finished marking every this term, so we don't know if anyone's got 100%. I think I've nearly caught up with the chat. Yeah, and Shrey's saying CSC Facebook group is a good first point of contact. Yeah, and the same thing that I was saying, Tom is saying that, like, asking me about other courses is a pretty bad idea, because my head is buried entirely in how to make 1511 work, and I only occasionally talk to the other lecturers, and we occasionally discuss how much information I need to get people up to so that they can have the start of their courses work properly. Hugh's asking, given my PhD, should point out I have not finished my PhD, so this is not something that I can talk about completing. But Hugh's asking about branches of mathematics closely aligned with deep learning and neural networks. And Michael's saying statistics, yeah. Deep learning has a lot of statistical calculation going on. So we're talking about floating point calculation. So knowing the idea of what it means to get a whole bunch of data and to process that data, in a sense, in a fine-grained way. So I think that is kind of floating point stuff. But the other thing about neural networks is, regardless of floating point bits and pieces, you also need to know about graph topology and things. So I think that could be useful as well. And so even things like discrete maths and working with mathematical graphs and everything that you're going to do in the core of a computer science degree, not everything is going to be useful for deep learning, but a lot of it is. So you need to know how to build graphs. You need to know how to build trees, and potentially even stuff like state machines. And then you want to know about statistical theory and things like that as well. It's pretty heavy. Ooh, I've been talking for a while. Screensaver just popped up. People are back to watching the stream. Actually, if I'm not if I'm not actively writing code. There you go. Nearly full screen chicken. Shrey wants to have a chicken date. Well, a cat date with my chicken. I don't know. Chicken is like a real homebody. Like, she likes me and my partner, but like seriously, when the doorbell rings, she runs and hides. We've had people cat sit, and for the first like 3 or 4 days, they're like, "We think we may have lost your cat. Like, we don't know where your cat is. We've left food, and that's all we're doing. But like, the cat has disappeared." And usually it's like, okay, this place under my desk or this place inside the bookshelf, this is where she is. And it's like, oh, okay, there you go, we found her. But she wouldn't come out. And it's like, yeah, she's just scared of people. Raghav, you left, but you heard chicken came back. And as Michael's saying, yeah, when I say trees, I'm talking about trees that are built up out of the bits that we make linked lists out of. So I would definitely, like, if you're going to go into that kind of thing, make sure you know your linked list stuff really well, because the idea of nodes with pointers is something that will definitely come back. It'll come back a lot, you know. And the idea of them just only being one dimensional, of just nodes linked together in a chain, is something that will disappear. Well, it won't disappear, but it will be added to very quickly. Yeah. Um. Rago was like, "Where's my quarantine beard?" I shaved this morning because I was like, I'm not going on stream looking like that, and I don't want you to know what I look like before I shaved this morning. Haven't you seen my quarantine hairdo? Yeah. You know what I had at, like, earlier through the term is, like, this entire thing was shaved, and so I looked cool because I had the stuff on the top that was going over, and everything underneath on either side was shaved. And now it's just like I just have this whole mop of hair on my head. Um, my hairdresser, who's actually just a friend of mine, is opening up her salon again soon-ish. So, like, I may be able to get a haircut soon, as long as, like, we're careful about what we touch in there and stuff. I did at the beginning think that I would grow a quarantine beard or mustache, but I decided not to because my genetics did not necessarily involve a nice, full, luscious beard, and it would just be like patchy chunks of hair on my face. I'm not sure I really want that. I'm not sure you want that either. Um, oh, Shrey's cat's in the Central Coast. They would probably know. You know, my cat's actually from the Central Coast. I adopted her, but like, apparently her and her sister were found in Newcastle. Well, it's not exactly Central Coast, but pretty close. Um, yeah, they were found in Newcastle, and somehow they came to Sydney, and we adopted them. Um, Michael, it's not the matter of buying me a haircut. I can afford the haircut. It's more the fact that I'm going to stay inside for as long as I can, because I consider the coronavirus thing, the idea that we want to stay isolated for a little while longer before going out. Although Australia is getting to the point where we've nearly gotten to the point where we've actually eradicated it entirely. Or we've gone to the point where there's a whole bunch of people who are asymptomatic, and the second we open it up, we're going to have thousands of cases. I don't know. I'm not an epidemiologist, so I can't answer those questions. Do we have any other questions that are 1511 specific? I think I've gone through and answered lots of things. So I'm not sure if there is anything else people want to ask about. I'll wait and see. Just drop your Steam URL. I don't know. Oh no, it wasn't this term. It wasn't this term, but it was last term. Because this term I was actually using a separate computer. I was using my work computer to lecture with. Because my work computer has a stylus that I can draw on screen. And so I was like, this is really great. I'm going to use this when I get to linked list. It'll be great. And then I left it there at CSE, and I never went back for it. But the term before, I had Steam still open in the system tray, and like I had friends' names popping up in the corner while I was lecturing, and that was pretty funny. Um, why would we talk about 1511 in a chicken live stream? So Tom's talking about tips for the exam. Oh, Nick's saying maybe we can do some code for question 10. We could potentially... You know what? I can actually, because I've got the solution code that I wrote here, I can show you that code. Okay, a couple of things we could do then. Let's talk about tips for the exam. One thing I'd say, we keep talking about like this potential for the 3-hour exam and stuff like that. I would ignore that. And I would say what you probably want to do is be patient with the exam, read the questions carefully, and every time you read a question, you can also go back and look over your notes for those kinds of questions. If you want to tonight, before you go into the exam tonight you could actually go through the content in the course and say, write down like a document somewhere, like a Google Doc or just like a document on your computer, and just say, if I need help in this kind of topic, this is where I look it up. So this is the lecture that had demos on this kind of thing. This lab had these kinds of questions. This weekly test had these kinds of questions. And so if you need to look stuff up, you can look stuff up quickly. Michael's got a good tip there. Get a lot of sleep. Plan when your meal times are. Make sure you take proper breaks. Don't work for more than 1 hour in a stretch without getting up and walking around. I say that with the deepest sense of irony because I didn't take a break during this stream and just kept talking. But you know. Yeah, it's actually pretty funny with a 24-hour exam because those of us who are invigilating it are taking some pretty weird hours. Oh yeah, Shrey's got a good point here. If you get stuck on something, like you get really, really stuck on one auto test in the exam, I would go off and do something else. So maybe do something else that just gets your mind off it. Or go off and do a different question for a little bit and then come back later. And if you really need to, you can sort of look up what it is that question is and go back and try to figure out through the lecture slides and things like that how I approached a similar problem. Most of the problems in it have similar problems somewhere. Or go back to the assignment and say, okay, how did I approach that problem in the assignment? If you did. And if you didn't, then you're in uncharted territory and you're like, okay, I'm going to have to figure this out. I would say maybe go back and look at the problem solving slides, look at the stuff I was talking about in solving problems and debugging and things like that. Because a few of those things I gave you some techniques which might work on any problem, which is like break it down into parts, look for the bits that do work, try to identify the bits that don't work, that kind of thing. And that is where your true skills are tested. You know, because I could test you on just what you can do with C, right? And that's a certain kind of test. But if I'm testing you on what you can do with programming in general, what I'm testing you on is like, can you shift your way of thinking around to solve problems? Can you debug something? Can you actually find out what is and isn't working in your code? This kind of thing is the kind of thing that tests whether you're a programmer or not, rather than just someone who can write C code. And so those are the things that I think will be good practice. And also, like, if you get stuck on one auto test and you just totally can't do it, you can just let it go. Because you don't have to be perfect, as I said, in this exam. Not everything has to be perfect. If you're stuck on, like, all of the auto tests for one of the first two questions, then I would say definitely that's the case where if it's a hurdle, you know it's a hurdle. Go back, go to the lecture slides for those particular topics, see if you can figure it out. So I've already given you a good idea of the format for those questions, for the first two questions. Those I would say would be very good ones to maybe tonight go, okay, these are the slides that I would need for this. Because both of those things I've done in great detail. So both of those things I've done in extended demos in class. So they've been there, they've also been in your labs and things like that. So it's kind of like one of those things of like, you do technically have the content to do it. If you've been able to keep up with it, you have the training to have seen it before. So the only thing we're asking you to do is to repeat things that you've seen. And so even if you haven't seen them before, go back and have a look at those lectures so you know which things to look for, you know which things to prepare, and you know that even if you don't prepare fully, the stuff is available in the exam for you to look at. Rago's asking what we do with the data from the auto test. We occasionally look at it, but not that much. Like, we would sometimes see, but not always. I think Tom, what Rocco is saying is the stuff that they can see is like 90-something% of people pass this auto test, 80% of people pass this other auto test and things. we're not really looking at that much. If we wanted to, we could look at that and say, this question has more, has been answered more than this other question, which means this is the average kind of knowledge that we've got in the class at any particular point. Part of me thinks that would be a really useful analysis, but another part of me works from the other direction of knowing how hard things are because I wrote them. But it actually would be nice to get some concrete data in return to see whether certain questions are people slipping up on certain questions. And sometimes that's just because we've written them badly, not even because the content's that hard. So maybe we'll use that at some point, but that's going to go on my list of things that I will do when I get time. And things that I will do when I get time usually get pushed so far that I don't get time to do them. But we see. We'll see how we go. What's an HREC problem, Tom? What else were people looking at? Oh, that's right. Sorry, chicken. I need to get my hand. Nick was talking about some of the code for the remove all highest. Now, I know that I've got my code for remove all highest here somewhere. Oops. Oh, I don't have it here. Where was I working on this code? Oh, right, human research ethics. Right, okay, so things that we don't want to do. Alright, let me shrink this back down. Okay, 20 minutes left. I'm not going to get that much of this done. Remove all highest.c. Let's have a look at some code. Okay, I'm gonna have to move chicken so I can reach my keyboard with both hands, although I don't have to move her that much. Oh, she's like totally like she has this thing sometimes where she's like, no, this is my spot. I've chosen this spot and I am keeping this spot. There you go. Now you've just got chicken. Or like if she jumps off, just a real awkward crotch shot of me. But anyway. So remove highest. Let's just... We're going to go fast here because we don't have that much time. So we're going to need a struct node. And this is going to have pointer to another and some data, which we're going to use as an integer. I don't know if we need our standard IO for the moment. Oh, we are actually going to need our standard library at least. I'm just going to include them both because this is one of those things that we think we're nearly always going to need these two. Alright, and I've got a function that says, well, I've got a few functions that I could use here. So I could have remove highest. Let's just say I definitely need one which says remove all highest. And I could have one that says remove. This is going to give me back a node pointer. And it's going to take a node pointer, which is the head. This one's also going to give me back a node pointer. So these things are going to have to return the head of the list, because if they remove the head of the list, then they will need to give back a different head than they were before. William's asking, coding questions in the exam, will we have starting code files for each question, or will we need to do some questions from scratch? You'll have both. So sometimes we'll give you a starting file that has a bunch of this stuff in it. and it says, this is the function, the only thing you can touch is this function. Everything else we're going to delete and reuse. So sometimes we compile your things by removing the main function and then putting our own main function in for testing. But some of them will say you need to make this file from nothing, because we do want you to be able to do that. So what I just did there, which is not that much coding, setting up the structure for a file that's going to be compiled, we do want to make sure you do that. Yeah, as Tom's saying, sometimes we go, okay, here's the file question3.c, and then there's nothing in it. And it's like, okay, you got the file, but you're going to have to make it into a working C file. Okay, so if I want to remove something, maybe I can have the head of the list, and I can have a value that I want to remove. I think that that's a function that I could use. I'm going to comment that one out for now and say, okay, what am I going to do? So let's make a linked list. I would normally put this in a function as well. So size of struct node, that's our head. Now head data equals 5. I should actually put this in a separate function. I just don't have much time. Let's do it anyway. Okay, create node. Here, int value, that's going to go there. It's going to return a pointer. That's going to go there. It's going to be an N. We'll take that line as well. That's a pretty useful line. Okay, and it's going to return a pointer to the node that it's just created. There we go. Simple create node. So I can have a struct node pointer head, and that's going to be equal to create node. I'm just going to put a 5 in there, and then I'm going to just do the simple list building, I think, that I've done before. No, I need to give this a next as well, because I don't want these next values floating around doing nothing. Struct node pointer next. So the next in the one that I'm just creating, oops, let me just move this code so that you can read it. And you can still look at chicken. Right. And next equals the next that we were given there. Okay, so that first one becomes the end of the list. And then I'm going to say the head becomes the new node. And that's going to be, I don't know, 10. Oh, it's not going to be null. It's going to be what used to be the head. So I'm just going to build a list like this, easy way. That kind of old but slightly silly way that we created lists in the beginning. That's fine. We will just have a 5 and 3 10s in the head, so we're going to need to remove all of the 10s from this list. Then I'm going to say head is equal to remove all highest of the head, which means I pass in one list and I want that list to be replaced with the list with something removed. Okay, so this is just the basic structure of what we're doing. Alright, just copy the whole first line. Right, so I got my function declaration up here. So I need to do a remove all highest. If I was going to do something like this, now some of this stuff is going to be code and some of this stuff is not. So some white space, so this is close to the middle of the screen. Find the highest by looping through the list once. So this would be something like int highest is equal to find highest head. I'm not going to write that function because I think that function is probably not where people are looking for help with. They're looking for help with, now that I have the highest, I'm going to remove the highest. So when I'm doing something like this, I'll do it the easy way first, and then I'll think about how to do it a harder way. So one of the easiest things that I can do is say remove. So let's just copy this. So easy way first. Remove the first element that has the particular highest value. So this is where I would say the head is equal to remove from that list the thing with the highest value. This is only going to get rid of one of them, but at least this is probably going to work. So remove, I'm not even going to write all of the code for this. Loop through until you find the node that matches the value. Remove that node. Okay, I don't need to write this code because I'm going to take a punt here. Might be it. Remove player, head of the list, returning the head of the list that matches this name. Insert alpha, remove player. Find the player to remove, which loops through the list. This loop stops with the current aimed at the removal target. If it's null, we're off the end of the list. Otherwise, remove and free the player, blah, blah, blah. So I could pretty much copy paste this code. It's not exact. I would need to modify it to do what I'm trying to do, but this is the code that I would use for removal, so I'm not going to bother writing it again here. So this is going to remove one node once. Oh yeah, this is when, no, you know when you weren't here for this one, Tom, you won? So I think you weren't here for one of the lectures, and then we, like, the students allowed you to win the Battle Royale at one point. But you weren't here, so you'll never see. Apart from that, it was recorded. Anyway, so I already know that I have code to remove something from a list that matches a value. And I think that this is going to remove something that matches the first one, because I think it loops through and finds it the first time and removes it. Which means this is going to work once, and it's going to... at least I think so. Someone can remind me if Tom actually won it. Yeah. James is asking, if you want to access your 1511 code stuff in the future, do you have to do something like in the terminal? As long as you continue doing CSE subjects, you'll have an account with CSE, and so you'll still have all of your 1511 code there. Having said that, you won't necessarily if you stop doing subjects with CSE. So if you think you're going to stop doing subjects with CSE, then it might be good to grab all of your code and copy it out. You could get some help with that in terms of like zipping everything up into a zip file and then copying it. but I think that you will still have access to it. I don't know. Yep, Tom's saying what I was thinking as well. Yeah, you could use something like SCP to copy it out. Okay, so head remove highest is going to definitely remove the first one. So in this case, it would probably take out this node. So oh wait, there's a reverse order. So this would be the head, then this, then this, then this. So it would probably knock out this node, and then it will return us a new list that had that node removed, which means we're one step closer to being complete. So we could start to think about doing something like this. While something, if we remove the highest a certain number of times, then we know we're going to be able to have removed all of the maximum in the list. I'll show you the easiest and dumbest way to do this, which 100% works. And I shouldn't have said dumb, because it's actually quite intelligent. I could say while length. Hang on. I'm going to do this. Int I is equal to 0. Int length is equal to length of head. And then I've got another function which is going to be called length of. What I'm doing here is I'm trying to do this in ways that is actually really simple code, just piecing together really simple code to do this. So length of struct node head, find and return the number of nodes in this list. So length is equal to that, while I is less than length. Do this. So, interesting thing that we're doing. I'm missing a semicolon somewhere. I think it's probably because I will be missing semicolons and things because I've stopped really coding here, and I've actually kind of doing a framework here rather than a coding. Yeah, there we go. Thank you. People are asking me how big the CSC database is. I don't know. In terms of how much space we have for all students to store stuff, it's massive, but I don't know how big that is. Oh, one of the weekly tests there was no room left. Oh no, that was on our end. There was just something weird happening there. James was saying, do I have to use RM? Oh, you don't necessarily if you're trying to delete. It depends if you're trying to delete everything or not. But if you're trying to copy stuff out, there are ways to actually zip up everything and then copy it all out as a single file. Anyway, let me go back to the code here. Okay, so here's this interesting trick. This loop says this loop will run once for every node in the list. So for example, if I have this, they're all the same and they're all the highest, this one's going to run 4 times. It's going to remove one of these nodes each time. But if I have something like this, where only one of these is the highest, then that remove is going to run more times than it needs to, but it's just going to remove that 20 because the 20 is the only one that matched the value which we got from here, the highest, and then it's just going to run multiple times. So this is how I'd do this if I didn't care about the fact that I was going to do this more times than I needed to, but I was going to do this with the easiest possible structures that I could use. So I have not done anything complex here. Like the remove code was literally in lectures, just how to remove. And then what I've done is I've gone find the highest, That's an easy thing. Loop through once to find the highest. Loop through another time to find the length. If I want to, I could do both of these in one function. So I could have pointers to integers and just write the highest to one integer and write the number of elements to another integer if I wanted to. But, you know, separate functions is fine, no big deal. So the length of, the remove, the find highest, which I didn't even put like this here. I just assumed that it existed. So these are things I think that you can write if you want to. And then all I did was, if I call this remove function on the highest once for every node in the list, then I'm covering the potential of these all being the same value. But also it just means that if I'm removing only some of the elements of the list and I'm doing some extra work, it's just more times that I run through the list. In terms of the human effort going into this is the easiest way that I would do this. There are other ways that I could do this. So I could do something like this. And I could say removed is the number of elements that were removed by this function. So if remove has an integer, I'll have an integer here saying int num. I'm removing my mother. Num removed is equal to, I'm going to say 1. And I'm going to say while num removed, keep doing this. Oh wait, this one needs to get the address of num removed. So this is actually how I did it in the solution, which means that this only runs a specific number of times. So what I do is I will, because this is a 1 in here, this is always going to run once. And what it's going to do is it's going to remove something from the list. If it does remove something from the list, num removed will be turned into a 1. It is a 1 already, so it'll stay a 1. If it does not remove something from the list, so the number of elements that were removed by this function is 0. So if it doesn't remove anything, it flicks this flag to 0. Num removed is 0. This while loop will fail and then we'll hop out. So this says that if I wasn't able to find the highest value in the list to remove, I will then just I will say that I did not remove anything, and I know that if I didn't remove anything, then all the highest have already been removed from the list. And then when that's done, I could return the head. So come back to me. So that's the kind of code that I would do to try to solve that particular problem there of remove all of the highest. So there's many different ways that you can do this, by the way. So this is one way where I'm saying I know that I have a single remove function, so I have a single simple remove function, and I'm going to do it multiple times. Another way would be to loop through the list and remove them as you go. And the only differences between these different ways of doing this, or me not even doing num removed and just saying, just run it X number of times. Because if you just run it X number of times, you're guaranteed to remove all of the highest, even if they are every single node in the list. So there's different ways of doing this, and the only difference is how many times they go through the list. We're not worried too much about how many times they go through the list, but if we really wanted to, we could go deep into this, and we could say, how can you reduce the number of times we go through the list? Can you go through and write this code so that it does the least number of possible operations to get done what it needs to get done? And that's something that you'll see later on. 1511, we're not worried about that. We're worried about just getting the code working. And later on, we'll do other things. What's going on in chat? Let me just check what's happening. Every student gets 500 megs. We have 5,000 students. Staff get more. Yeah, there's big banks of computers that are just storage for everyone. Do tutoring to get more space. You get more per courses as well. Some courses give you heaps. It depends on the course itself. So if a course requires you to store a whole bunch of data, then they'll ask the systems people to give everyone in that course more data. I can't think of which courses do that though, but some might. Yeah, Michael's also saying you could keep your own stuff on Git or something like that. It's not a bad time to start learning about that in between terms. You'll get asked to think more about that the more subjects that you do. Git is a really, really useful system that allows you to keep track of the changes you've been doing on things while you're backing them up, in a sense. Oh, James just looked up man length of in the terminal. Was that that was a coding block, wasn't it? Yeah, no. I was expecting you to make that function yourself. So it is not a C function. It is here. I mean, it's not that hard, right? You loop through, and every node you see, you add one to a number, and that's the number that you return at the end. Um, Peter's wondering if anyone else got enough space to upload a game and play on VLab. I mean, yeah, people do make games. I mean, it's part of computer science to know how to make computer games. Like the people who are making computer games, well, not all of them, but a good 20-30% of the people in the computer games industry are programmers. There's way more artists than are programmers because you can just see how computer games are very, very 3D art intensive more than they are programming intensive. Um, yeah, but there is. I used to have an arcade machine emulator running off my CSE account um, when I was a student. We were not kicked out of labs for playing arcade games in the labs. Yeah, so there's stuff like that. I mean, there's still you're still running on VLab. I would not want to play a game on VLab. That input lag would be pretty bad. But if you had turn-based games, stuff like that would totally work. Um, chicken access. Um, there is a course that is kind of a zombie course now in CSE called the Game Design Workshop that used to run. It's not really about making games, but it's about thinking about how to create them. So we actually did things like making board games and stuff like that, which was on a build up to how computer games are actually built. It was more about user experience at that level of thinking about games. I have thought every now and then about putting together a games project, but it's really hard for me to think about doing stuff like that while I have this commitment to 1511. So it's kind of if I do want to do some of the other courses that I know how to teach, I'm thinking of reviving the graphics course sometime in the future. It means I have to think really carefully about what the very first experience people have when they come into CSE is. So 1511 is really specifically crafted so that it works for people. So it kind of works for people who have coded before, and it works for people who have never coded before. And you can see the way I teach, right? The way I teach has a whole lot of I want to teach you about the enthusiasm and the sort of the joy of what it means to program, regardless of whether you actually get good at it or not. I actually don't even care if you're good at it or not. But if you like it after this, you'll get good at it eventually. So that's the aim. And so it's really difficult for me to think about all these other courses that I want to run because 1511 is a constant thing every single term of the year. So there's always going to be this back and forth between whether I try to revive things like the games course and the graphics course, or whether I stick to 1511 and make sure everyone gets a really good entry into CSE at UNSW. Very difficult. Yeah. Tom's saying something about tutoring. People are wondering about tutoring. We definitely do hire people to tutor. There are some people who have already been mentioned to me by your tutors. I haven't put the full call out yet, but usually the short list of people that we go to try to decide whether we're going to hire people or not in the future, um, is based on activity in tutorials. Um, like there'll be a bit on your marks. There's also activity on the forum that counts as well, that kind of thing. But we don't hire people based on how good they are at coding. We hire people based on how good they are at transferring ideas, because hiring a tutor is not about hiring someone that's just really good at stuff. It's about hiring someone who can get those ideas into other people's heads and also understands a lot about the struggle of trying to learn something when you don't understand it. So there's actually a happy point of a certain level of struggling student that makes the best teacher. I like to think that that's in my personal experience as well. The road for me to becoming a lecturer was was paved with roadkill and potholes the whole way. So as a starting out lecturer, I'm a lot older than most people are when they start out lecturing. Um, oh, the email went out earlier today. So there's an email that has gone out for applications for tutoring. I didn't know that that had been sent. Obviously, I don't receive student emails. So a lot of you will probably have received an email from Andrew Taylor. I think most everyone in the course will have. I mean, it doesn't necessarily go to people who are not computing majors, but sometimes it will anyway. Um, you can apply to that and put information in. One of the important things in there also is, especially in this online age where we haven't been able to meet as many of you in person, is to record a little video of yourself doing some teaching. You can teach stuff out of the course, out of Comp 1511. No worries about doing that. Or you could teach something completely different if you want to. It's usually like I will watch those videos to see the manner in which someone presents themselves. If you've been active in your tutorial and things like that, chances are you'll have a recommendation um, from your tutor that you might be a useful person to teach. If you've been pretty active on the forums helping people, that's another thing that we might see that's like, okay, there's a reason to look into that person. Because at no point are we going to look into all 700 of you. Oh, hang on, somebody's moving around. Maybe people want to talk to Chicken for a bit. Yeah, so um, it's always worth applying, but there's always going to be a few things that will determine whether or not we will look at your application or not, and at what level we're going to look at your application, because we do need to know that people are able to handle teaching the content. Oh, Georgia, that is like totally fine, by the way. Like, if you do want to apply and you have friends taking the course next term, there's nothing wrong with that. Like, we do have that as a reasonably common thing that happens, and we will usually just make sure that you're not assessing. Like, there's a certain distance between you and your friends, and you're not assessing the things that they're doing. So, we have had that in the past. I mean, CSE is not a huge community, and if you're active in things like CSE Soc and stuff like that, or CSE Review and stuff, you're going to know people and you're going to be friends with them. And we just take care of things like conflict of interest and stuff like that. So if you just let us know who your friends are, we can make sure that your schedule and your marking schedule don't line up with them. Yeah. So like we can deal with that if you want to. Yeah, but still totally up to you, you know, like if it's a personal thing and you don't want to be tutoring while your friends are in the course, then that's totally fine. But if you want to be tutoring and you have friends who are going to take the course, that's not a reason why you shouldn't apply or anything like that. Oh my god, I'm being groomed. Here's a very special moment from Chicken. Oh, we call this ice cream whenever she does this, because it's like I'm holding an ice cream and she's licking it. Okay. I've gone over time, so I think this is time to wrap it up. I hope we've answered a few questions, or even if nothing else, we've just hung out and had a bit of a relaxing time in the lead up to the exam. Um, it's it's been yeah, reverse Uno card on the pats. Chicken actually does pat me sometimes, where she sits there and she puts her hand on my shoulder. It's usually not a pat. It's usually you need to feed me now. But anyway, we're gonna wrap it up here. Someone needs to eat their daily dinner, so I'm gonna feed her. Um, it's been nice hanging out with everyone. I apologize that it's all been online. Although the funny thing is, this being online has actually given me more of a chance to talk to a lot of you, because usually I don't get any feedback in lectures because there's no open chat channel for people to be able to talk to me in lectures. It doesn't really work that way. So it's actually been nice to have this back and forth with a lot of different students during the streaming half of the course. Well, Raghav, I'm glad that you're excited about learning more about coding and stuff like that. It'll be super interesting. I also had a really fun time. My computing degree was kind of interesting. I had a fun time at the beginning, and then I had a bad time, and then I had a fun time at the end. So don't even worry if it gets worse and some of your subjects aren't great, because it's it's just kind of part of the dramatic arc of your journey through university. I didn't settle on computing until I was in my third year. I kind of didn't want to be in it in my second year. So things will get weird, but things will be interesting. Or they might just be smooth sailing for you. You might love it the whole way, and I will take full credit for that if that happens. But anyway, yeah, hero's journey. You're all the hero in your own hero's journey. I get to be the mentor, the first mentor that takes you on the journey. I'm your Obi-Wan. Anyway, I should head off. Gone overtime anyway, so I'll wrap it up here. Good luck everyone tomorrow. We're all here, all your tutors are here, and we're all barracking for you, even if we're not allowed to help you, because we're obviously not allowed to help you during the exam. We all want you to do the best you can, and we hope that all the best happens for you. May the 4th be with you, and we'll see you all tomorrow. Well, I mean, like, not necessarily see you, but we'll know that you're working. So yeah.